Hello everyone. This is a video lecture for College Algebra, Math 1314, Section 4.3, Properties of Logs. So we're going to learn how to expand and condense logarithmic expressions. So this is going to be expand for the next while, actually. And there's three formulas that we need to learn, and it just so happens that each of these coincide with each one of them. We have the product rule, where you got log of m times n on the inside will be a log m plus a log n on the outside. You have the quotient rule, where the log of m over n is log of m minus log of n. So division becomes a subtraction on the outside. And then you have the power rule, which is log of m to the p power. What happens is the p comes to the front. P times log of m is your answer. And so we're going to basically go from these condensed forms over to the expanded forms. And for each one of these, it's not very hard, but we definitely have to talk about it. So notice that this is a multiply right here. Is that 6 times x? And so there's a times in there. So we got log base 6 of 6, and then a plus sign, log base 6 of x. We're not quite done because 6 and 6 can cancel to make a 1 there. And they do want it fully simplified. And so that is your answer for this problem. Okay. Division. Notice that we have a divide symbol. Well, now that's going to be a subtraction on the outside. Now, again, we can try to cancel something. This is a log without a base, which means it's base 10. And so I'm saying 10 to what power is a 100, and that's a 2. So this whole thing right there becomes a 2. So you actually got log base y, log of y, and then minus the 2. This last one's super easy. You take the 3, you move it down to the front. 3 log base 7 of x. There's nothing else to do, so you just leave it alone, and you're done. I'm going to be using these properties as we keep going through all these problems. So here's another set of problems. And again, we're similarly using them. Well, there's a division, so the first thing I think of is put a subtraction between them. So ln of e to the 7th, and now minus ln of 5. Well, then e and ln cancel because ln is log base e, and the e's will cancel, leaving just the 7 behind. And so that's actually your answer there. Pretty easy. The power for a 15th root, so that's all one power there, and it can be brought to the front. What is that power? Do you know it? It's 1/15. So ln of x, there you go. Yet again, you're done. This one's a little bit longer. We've actually got a division, so I've got to split this up with a subtraction between them, like this. And I could simplify two things. First off, this square root is going to be a half power. So that will come to the front, and that's done. 6 and 36 actually are going to cancel here. Again, I'm saying with this chunk, we can go back to the last section and say, okay, well, 6 to what power is 36? And it's a 2. And so this whole thing here could be replaced with a 2. And there's your final answer. Okay. Keep cruising. So it says to expand. And again, this is kind of like simplifying. I want to say the word simplify, but simplify is too vague. We need to just say expand. So the first thing that comes to my mind is that division. And so I need to split it up. You always got to have a base b. Very particular on the homework program. And so a division is going to be a minus sign. Okay, well, notice here that this is a multiply between these two right here, right? There we go, multiply. So I'm going to split that up to be with a plus sign in between them. Again, the log base b for every single one of them, no matter how annoying it is. Okay, now I could use the power rule. I can bring the 2 to the front, the 3 to the front. There's nothing here to do. So we've got a 2 log base b of x plus log base b of y minus 3 log base b of z, and that is your final answer. Wow. So I'm feeling like this is getting a little bit cumbersome to use these three rules because they're going to be longer and longer, more and more steps. There is a shorter rule that you could use, I suppose you could say, maybe like a guideline. But this is just what I would do. Anything that you find in the numerator, any term that you find in a numerator, it'll have a plus sign in the front of the log. And anything that you find in the denominator, if I can spell that right, will have a minus sign in the front. And so I want to use this new rule with the next one. And I'm going to just show you how this will work here. Actually, you know, this one here is not exactly easy to work with. This one, it's the one after it that's a little bit better. But, you know, I'll do it with that. But let me do it with this one. I'll show you that this is actually going to be faster. So here's my new one. And so every term that I have in the numerator, I'm going to put a plus sign in front of the log for it. That's in the numerator. So I got a plus sign in the front of the log for it. This one's a minus sign because it's in the denominator. So he'll have a minus sign there. Oop, there's a cube for that guy. Z cubed. And so my only other step is to bring the 2 and the 3 down, and you're done. You don't have to worry about all these divisions and multiplies and all that kind of stuff. It just is kind of done for you. And so I recommend using it. I'm going to use it not on the next one actually, but the one after it. This one here is it's a little different than the others. I put it in here because obviously I want to show you what to do with this kind of problem, but I wouldn't say that it's characteristic of all the problems. Not at all. It's kind of its own guy. First off, I see that the whole thing has 1/6. Notice that that's a 1/6 power. That's a divided by b all to the 1/6. And so I could bring that down to the front. And now, I know it looks like a 9. That's an a, and that's a b. And now I'm going to split them up as a division. The problem with this problem is that people get it wrong because the 1/6 they don't apply to both. They only apply to the first one for some reason. Well, the 1/6 is actually for both of them. And so however the homework problem program wants it, either like this or like this, regardless, that 1/6 is definitely for both terms. I'm going to call it there. So watch out for that small stuff there. Okay, I want to go back to this formula for this one. And so this is a really big problem. And if you were to do this one by one, it would take you a very long time. But I'm going to show you that the quick method that I'm going to show you is much easier. So again, numerator, plus sign, denominator gets a minus sign. So here we go. Numerator term, that's going to have a plus sign in the front. Numerator term, and I know it looks kind of weird, but that's x to the 4th and then a cube root. So watch out for the font there. Very confusing for no reason at all. Okay, now we got the cube root is still in the numerator, so you put a plus sign in the front. You got a cube root, just whatever that term was. Now we look at the denominator. Well, here's a term in the denominator, so it gets a minus sign in the front. And this is also in the denominator, so it gets a minus sign in the front. Let me use 2 parentheses for this guy. Okay, so now we got to simplify it. One last step, and then we're done. Well, this is technically a base 10. And so I'm saying what power, 10 to what power is equal to 100? And that answer is a 2. So the whole thing here turned into a 2. Over here, the 4 can come to the front. I got a 1/3 that can come to the front. This is just nothing. You just leave it alone. There's nothing to do there. You can't simplify it. And then you have the 2 that comes to the front. You're done. You're done with that entire problem in 2 steps. So there you go. And that's why I use this style, this numerator-denominator thing. It's so much faster than starting with division, and you like start, make mistakes with your distribute stuff, and it's just, it takes forever. And this is so much easier. So just use that method. It should be fine. All right, cool. There's one other thing I might mention. Notice that we have 9 minus x, and I'm thinking, oh, well, there's a rule for that, right? Minus sign means division on the... No, 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 no. Minus sign on the outside is a division. And so, oh, I see this plus right here, x plus 1. Plus means multiply, right? Not in this case. That's on the inside. There's not a rule for that. Plus sign here, that's going to be a multiply on the inside, but not this guy. Not that. Let's keep cruising. Now, what we're going to do now is not expand, but condense. I think I'm spelling it right. Condense. We're wanting it to put it into a single log. We're going backwards, essentially. And so to go backwards, what we need to do is the power rule first, and then we go back to the product and quotient rules. So power comes first. And so now we got log of z to the 2 power, z squared. Well, there's a plus sign in between them, and that's going to mean a multiply on the inside. Single log with a multiply on the inside between these two terms. Let's do another one here. So notice the first term is, the first thing I'm going to do is the powers. So ln x plus 8 all squared. Ln x to the 4. Well, minus sign means division, right? So one big ln here, got x plus 8 squared, and then x to the 4, like that. This is it, you're done. We're not solving for x here, we're not doing anything like that, we're just, simplifying, I guess you can say, condensing, expanding, whatever you need to do. That one looks pretty big, so there's a lot going on here. What I want to do is the powers, but then also... I don't know. It's just a tough problem, honestly. Notice that there's a plus. That means he's going to go in the numerator. Minus, denominator. Minus, denominator. So do not touch the 1/3 yet. He's a little bit different, I guess you can say. And we'll figure him out here in a second. So this is the 2 that can come up, and there's nothing else. So it's still going to be a square, but because it's plus sign, it's numerator. So x plus 3, then squared. And then in the denominator, I got an x. Then I also got this whole x squared minus 36 thing. Lots of stuff there. I think what we need to do now is bring the 1/3 up. And I don't know how the homework program's going to like this, because it is a very strange way of writing this. Like, does it want it all of this to the 1/3 power and we're good? Or does it want a big cube root for all of this stuff? And honestly, I'm going to tell you, I don't know. It does not depend. I just don't know. So try one. If it doesn't work, try the other. Both of these are good. They're both legitimate. I mean, I believe that I've tried both and they both work, but I might be wrong. So just watch out, okay? It's just wanting to know, hey, what are the steps, and what would you do? What does it look like? And we definitely have the look of it here, okay? That's the main part. So let's keep going. So this problem here is focused on a formula called change of base, or change of basis, either way. It's a small formula, so log base b of m is equal to log of m divided by log of b. And there is another version to this. We're not going to use it right now, at least, but it's out there. You can use an ln in place of a log, and it would be the same thing. In the end, though, we're just focused right here, right now. You can change any log base to 2 separate logs, and you can do this now in the Desmos Scientific without having to go to Desmos Graphing. I wouldn't say that it's more efficient or anything, but it is a way to get around it if you need to. So you would just rewrite it, log 16 divided by log 18, and there you go. I mean, the logs don't cancel. You can't just say, oh, they cancel, or maybe it's just divided by 18 or something. No. It's a very particular formula. put this in and get an answer, okay? Now, I know that you could simply go to Desmos Graphing and put this thing in, and you're done, but that's not the point, I guess. Just want to make sure that you could see the formula, 0.95924, etc. It's good enough. You just round it to whatever they say. Notice that they have a pi here. I almost did not include this problem, but I just felt like I needed to talk about the pi. So pi is equal to 3.14, correct? Well, yeah, but pi has a lot more digits than that, and your homework program is going to be upset with you if you don't use the pi button. So when you're typing this in your calculator, use your pi button, and that way it uses the most decimals possible. I'm just typing this in the calculator. Any old scientific work, Desmos Scientific, Desmos Graphing, doesn't matter. I got 3.434719. That's your answer for this. You're done. Round to whatever decimals they want. But don't just put 3.14. It's not enough for what you're going to be doing. I know that at least. Okay? All right, number 9, and this is the last one, but it's definitely tricky and different, and it's just strange to talk about, honestly. So let's get through this. Let's work on it together. They say we got log of 7/2 is equal to what? Given that we have these other letter things. Well, they want you to expand it, and so log of 7/2, notice that we have division, right? So this would be a log 7 minus a log 2. And what I'm doing now is I'm going to look around and see if I got anything that makes sense with this. Well, log 7, oh, I see that. It's right here. It's a Q. And then, log 2, I have that. It's a T. And so that's actually your answer that you're going to type into your homework program is Q minus T. That's it. That was it. That's all you got to do. Kind of easy. Okay, let's try this guy. So I forgot to add one thing here. It's log base 6. Okay, now we can talk about this problem. No, wait, no, it's not. It's not a log base 6, my bad. Okay, no, we're good. I was just thinking something. So, the key, if you can tell already, it's going to be 2, but let me go ahead and go through it with you. So, I think that I can see that I can get a 6 there somehow. So what if this was 6 squared? See, I'm going to change my 36 to 6 squared. And then if I take the 2 and move it out to the front, I got a 2 now. And then a log 6. Thing is that we have log 6. It's right here. It's j. And so your answer here is going to be a 2j. That's what you're going to type for the answer. It's a little weird to be able to convert that over, but that's how it works. Go through a couple of these examples because, I mean, they're just different. They're not hard. They're just different. And, well, that's all I got. So, thank you very much, and have a great day.